Hello there, Mr. Sutton here, bringing you the Algebra 2 9-2 homework solutions on samples, populations, and hypotheses. For this problem, they want us to identify the population in the sample. So the situation in the U.S., a survey of 1,152 adults age 18 and over found that 403 of them occasionally pretend to use their smartphones to avoid talking to someone. Oh, that's interesting. So the population here is going to be all of the adults ages 18 and over. That's the group that we're talking about here. And the sample is the piece of this group that we're talking about. That's the 1152 adults. For this problem, we're trying to figure out the sample and the population. So in this case, we have to estimate the battery life of tablets sold on a website. A consumer electronics team tests 6 tablets and finds they have an average battery life of 9.1 hours. So the population in this case is all of the tablets sold on the website, and then the sample is just the 6 that they actually tested. For this problem, we're identifying population and sample. So we've got a survey of 1,270 students at a high school, and that finds that 965 of them felt added stress because of their workload. So the population in this case is all of the students at this high school, and we've got just the 1,270 students in the survey. That's going to be the sample. I know it seems like, that many students might be all the students at a high school, but they didn't actually spell that out. And in fact, there are plenty of high schools that have well over that number of students. For the next few problems here, we're trying to figure out if the numerical value in question is a parameter or a statistic with some reasoning thrown in. So in this case, they're saying average cost of admission to some amusement parks in a state is $36.93. All right, well, since this is only some amusement parks in a state, this would be a statistic. It's a value about a sample, not about the whole population. So some amusement parks, not all, makes this a statistic. For this problem, trying to figure out if we're talking about a parameter or a statistic, we have each visitor to a website receiving a survey via email, and the mean age of all the people who respond to the survey is 26 years. So in this case, even though it's all of the people who respond to the survey, this is not all the people necessarily who actually visited the website. So this would still be a statistic because we're just talking about a sample of all the visitors to the website. On this problem, we're trying to figure out if this is a parameter or a statistic. So they said in a recent year, 54% of the seats in the U.S. House of Representatives were held by Democrats. Since we're talking about all of the seats in the House of Representatives, it's a fairly small population, only 400, I think 435 or something like that. Since we're talking about the population, this 54% is a parameter, not a statistic, because it covers everything. For this problem, we use technology to simulate flipping a coin 25 times, and the results are in the bar graph. What proportion of the 25 flips resulted in tails? Well, the total number of tails, according to this, is 14, and they actually literally spelled it out in case you weren't sure about that 2/3 of a grid line there. So 14 over the total of 25 gives us the proportion. And we can turn that into a decimal if we would like. I believe that's going to be 0.56. On this problem, we use technology to simulate rolling a die 50 times. The results are shown below. What proportion of those rolls resulted in a number less than 3? So numbers less than 3, that's just going to be the 1s and the 2s. So let's add those up. For 1s, we've got 4 of those. For the 2s, we've got 12, so that's 4 plus 12, giving us 16. So we have 16 over the total rolls, so 16 over 50, that's our proportion. We could reduce that, or we could just turn it into a decimal. If we do a decimal, this is just going to be 0.32. On this problem, we flip a coin 4 times and do not get tails. We suspect the coin favors heads. The coin maker claims that the coin does not favor heads or tails. You use technology to simulate 200 random samples of flipping a coin 50 times, and the histogram shows all those results. So what should we conclude if we flip the actual coin 50 times and get the following results? So for part A, we got 27 heads. So the proportion that we got there is 27 over 50, which we could turn into a decimal. That's 0.54. Now, how does that proportion compare to the simulated flipping that we did over here? Well, if we look at 0.54, that's this bar right here, that's surrounded by a whole lot of other results. There's a pretty high frequency for that one, and also for the numbers pretty close to it. So since our simulation results are clustered near the number that we got, that suggests that we can verify the claim of the coin maker that this coin does not favor heads or tails. It's a pretty even, fair coin. Now for the other situation, 33 heads, the proportion on that, 33 over 50, that's 0.66. Taking a look at that in our simulation, that's over here. There are not a lot of results really clustered near there. There's a few to the left, but very few as we move further to the right. So relatively few results near 0.66. So this claim that it's a fair coin is likely going to be false then compared to the general population here. On this problem, we spin the spinner here, shown 6 times, and get red 3 times. We suspect this spinner favors red. I mean, theoretically you have a 1 in 4 chance, but you got red half the time. That is a little suspicious, but it is only 6 times. The maker is claiming that the spinner does not favor any color. You use technology to simulate 200 random samples of spinning this thing 100 times, and the histogram has those results. What should you conclude when you spin the actual spinner 100 times and get the following results? So 56 reds and 29 reds. Let's do the 56 first. The proportion of red there is 56 over 100, which is 0.56. Comparing that to the results from our simulations, 0.56, well, that's not even represented here. There's no simulation results that even came close to 0.56. Since there's no simulation results near that, that most likely shows that the maker's claim is false. This is not a fair spinner. Now let's test our other situation 29 times. That ratio is 29 over 100, or 0.29. Taking a look at that frequency, that is, let's see, here's 0.28, here is 0.29 right here. So that's surrounded by a good cluster of simulation results. There's a fairly high frequency of things. It's pretty close to the highest result at 0.26 here. So because this has a lot of sim results that are near it, we would say that the claim is likely true then. This could easily have gotten 0.29 by chance rather than by a crooked spinner.